Hi everyone. Let's refine the graph of y equals x squared minus 6x plus 5, our old friend. We saw where the vertex was, and we saw that it opened upward. But aside from the vertex, what are some other interesting points we might want to find? What's true for any graph in the xy plane? What points might we want to find? We might want to find the intercepts. And which intercept is normally easier to find, y-intercept or x-intercepts? I'd say the y-intercept. Because what do you do to find a y-intercept? You set what equal to what? You set x equal to 0. You plug in 0 for x, and you evaluate f of 0. And what happens when you plug in 0 into the right side? It's an easy evaluation. What happens? These terms drop out, and you're left with the constant term, 5. F of 0 is 5, which means that the y-intercept is at the ordered pair 0, 5. Back in my day, we were lazy. We just said 5. You should say the ordered pair 0, 5. In general, if you have y equals ax squared plus bx plus c, then 0, c, where c is the constant term, that's going to be the y-intercept. Just as if you have slope-intercept form for a line. What was slope-intercept form for a line? It was y equals mx plus b. And once again, the constant term basically gave us the y-intercept, 0, b. Let's do a demonstration. Let's graph y equals x squared minus 6x. Here's y equals x squared minus 6x. It passes through the origin as the y-intercept. If we go y equals x squared minus 6x plus 5, moves it up 5 units. The y-intercept is now at 0, 5 on the blue graph. Now, how many y-intercepts can something like this have? How many y-intercepts can it have? It has to be exactly 1. There has to be a y-intercept because 0 is in the domain. There's going to be a point. But can we have 2 different y-intercepts? Is that possible? The answer is no, because then you're going to fail what test? The VLT. So this can't happen. There has to be exactly 1 y-intercept. However, think about x-intercepts. How many x-intercepts could a parabola have, a vertical parabola? Think about it. Well, you could have no x-intercepts, like a flying parabola. You could have 1 x-intercept. It bounces off the x-axis. The vertex is on the x-axis. Or you could have 2 distinct x-intercepts. And it turns out this guy will have 2 distinct x-intercepts. Find the x-intercepts, if any. Remember, there could be none. We could be in this case. We could have 1 or 2 also. How do we find x-intercepts? We plug in y equals 0. Or the function guy equal to 0. But wait a minute, that's harder. Why is it harder? Imagine plugging in 0 for y and solving for x. Why is that harder? It's harder because you have to solve an actual equation. You have to solve y, or f of x, equals 0 for the real solutions of x. Remember, only take real solutions. Only real zeros for the f function will correspond to the x-intercepts. Real zeros correspond to x-intercepts. Remember that from 1.2. So what are the real zeros of x squared minus 6x plus 5? One way to do it is to apply what formula? The quadratic formula, the QF, which we'll mention later. But it turns out that this QD can be factored nicely. How do we factor it? Remember, we're setting y or f of x equal to 0 to find the x-intercepts. We can factor this QD, and it turns out to be the factor x minus 5 times the factor x minus 1, or vice versa. The zeros are therefore 5 and 1. Which means that the x-intercepts are going to be at the ordered pair, 1, 0. Remember, they should be ordered pairs. And the numbers here are x-coordinates. Also, we have an x-intercept at 5, 0. So we're going to have here 2 x-intercepts. Now, we're in this case over here. We have 2 x-intercepts. But can you give for me an example where we're going to have no x-intercepts? What's an example of a graph that's going to look more like that? And I'll give you a hint. Can you think of an expression in x that has no real zeros? No real zeros. Here's a hint. Here's y equals x squared. It has 1, 0 at x equals 0. In fact, that's an example of the 1 x-intercept case. Y equals x squared. That has exactly 1 x-intercept. But what could you do to the parabola to make sure it has no x-intercepts? You could, for example, add 1. Notice there are no x-intercepts. And why is that? Because x squared plus 1 has no real zeros. There are no real values for x that will make this whole thing equal to 0. I doesn't count. All right. So we found the x-intercepts. And we mentioned the example y equals x squared plus 1 that has no real zeros and therefore no x-intercepts. Right? Let's verify what we have so far. Okay, so y equals x squared minus 6x plus 5. Let's look ahead. Let's ask Desmos. So what is y equals x squared minus 6x plus 5? Okay, remember we got the vertex from before. We got the vertex at 3, negative 4. That's what we have so far, right? It's the turning point. The parabola opens upward. We have the y-intercept at 0, 5 up there. And we have 2 x-intercepts at 1, 0 and at 5, 0. By the way, don't be spoiled. We're not always dealing with integers, but here all these coordinates are integers.